Okay, good afternoon all of you. Welcome back to the All 4 e-learning YouTube classes. This is Srinivasu. I am working as a IT faculty from 15 years past. Now, I will introduce the topic name is vectors in our EAMCET classes. Okay, this is nothing but the day 1. Right. So, in our vectors, first I have to go from a physical quantity. Physical quantity. What is meant by physical quantity? Physical quantity nothing but a quantity which is measured. A quantity which is measured means, first of all, what is the definition of quantity? Quantity nothing but anything which can be measured. Anything which can be measured. For example, let us say if I am taking 4 kg, if I am taking 4 kg mass of the body, let us say 4 kg. Here kg means unit. Here 4 means numerical value, means mass of the body, it is nothing but 4 kg means here any physical quantity that can be represented by numerical part into unit. Numerical part into unit. That means, listen all of you, this 4 kg which is measured by using common balance, that is the direct method. And I am giving us another example. Let us say if the height of the person is, for example, let us see here I am taking a person which is standing on the road. Now what is the height of the person? What I am giving? Let us say h is equal to 6 feet. H is equal to 6 feet. That means the height of the person which is measured from the ground is h is equal to 6 feet. Means feet is nothing but the units. 6 means numerical value. That means this height of the person which is measured from the ground by using meter scale. By using meter scale. Now let us say this is also. That means the height of the person which is measured from the ground by using meter scale means the height of the person which is measured directly by using meter scale. Okay, so these are the simple examples for the physical quantity. Now listen all of you. In our vectors chapter means that in total physics, the physical quantity which is classified into actual 3 types. Physical quantity means anything which can be measured. Now listen all of you. Again, this physical quantity which is classified into actually 3 types. First one is scalar. Second one is vector. And third one is tensors. What is meant by scalar? What is meant by vectors? What is meant by tensor? Scalar is nothing but a physical quantity which is having only magnitude but no direction. That is one type of a scalar. Scalar nothing but I am taking the examples like mass, distance, speed, etc. And vector has a physical quantity again. It is having both magnitude and direction, as well as it obeys the laws of vector addition. That means, what is the examples for these vectors? Like displacement, velocity, acceleration, etc. So what is meant by tensor again? So tensor has no physical significance in our vectors. That means tensor, it is nothing but a physical quantity which is having both magnitude and direction with varying quantities. That means it is a physical quantity which is having varying magnitude, varying direction. That means, what is the example for this one? Pressure. So I am explaining clearly. So what is meant by scalar means, scalar is nothing but a physical quantity which has only magnitude but no direction, as well as it doesn't obey the laws of vector addition also. So I am giving the one example for this one, classification of vectors and scalar. That means you know this. Electric current. I am giving simple example to describe the physical quantity which is nothing but a scalar or vector. Electric current. So is it the electric current is a scalar or vector? Is it the electric current is a scalar or vector? Electric current means, suppose for example let us say this is the conductor. This is the conductor which is connected to the battery, means due to the potential difference some current which is passing through the conductor. That means if the current which is passing through the conductor means this conductor having certain number of charges, means that number of charges which is passing through the wire and it has some direction, means this current having magnitude as well as direction, but it is a scalar. Why? Because it doesn't follow the laws of vector addition. That means, listen all of you. Here what I am giving, this is our previous knowledge as per the 10th class syllabus. Let us say this is the incoming current I, this is the outgoing current, let us say I1, here I2. Means these two branches which are inclined by an angle theta. Suppose the incoming current I, then what is the outgoing current at the junction? I is equal to, as per our knowledge, I1 plus I2. This is nothing but the Kirchhoff's first law in our second year syllabus or 10th class. So let us say I is equal to I1 plus I2. That means here, listen all of you, this electric current which does not obey the laws of vector addition means, so I have to take the controversial condition for this. That means here I am taking like this also. That means the incoming current is, let us say, here I1, here I2, then what is the outgoing current? I. Again here angle theta. So is these two are same? Not same. Why? Because here I is equal to I1 plus I2, here also I is equal to I1 plus I2, means I1 plus I2 is equal to I. Means magnitude remains same, but the direction is opposite sense. That means there exists an angle in between the I1 and I2. There exists an angle in between the I1 and I2. This is in opposite sense. That means here it doesn't follow the law of vector addition. That means here I1 plus I2 which is not equal to I2 plus I1. Okay. Now listen carefully. That's why electric current is a scalar. But this electric current having both magnitude and direction, but not obeys the law of vector addition. Means it doesn't obeys the law of vector addition. This is, that means electric current is a scalar. Okay. Now, so these are the examples for scalar and vector. Scalar means a physical quantity which is having only magnitude but no direction, as well as it doesn't follow by vector addition. Here what is the meaning of vector? Vector is nothing but the physical quantity. It is having both magnitude and direction, as well as it obeys the law of vector addition. Now what about the tensor? Tensor is nothing but a physical quantity, but it has a varying magnitude, varying direction. How it will happen? For this tensor I am giving the one example for you, means pressure. I am explaining how the direction and magnitude are changing. Let us say, you know this is the closed vessel I am taking, means one side is open, one side is closed. Now let us say this is the liquid which is poured into the vessel. Now what I am doing, suppose this is the body which is immersed into the liquid. That means if the body which is immersed in the liquid, means the liquid applies the same amount of forces in all directions. Is it correct? Now this force which is perpendicular to the surface, that means pressure is equal to, what is the formula? Pressure is equal to perpendicular force per unit cross section area. So here, listen all of you, here the force which is applied on the surface of the body by the liquid is changing, because here which is acting downward, here the force which is acting towards left, here the force which is acting slightly upward, here upward, like this. That means the force direction which is varying, as well as magnitude also varying. That's why this pressure having varying magnitude, varying direction at different points. That means this pressure is nothing but a tensor. Okay. So these are the classifications of physical quantity like scalars, vectors and tensors. That is. Now listen all of you. So after completion of this classification of physical quantity, actually the vectors which are classified into so many types, on that I am explaining the concept of unit vector. What is meant by unit vector? For example, let us say for this I am taking three-dimensional reference frame like x, y, z axis. This is nothing but the rectangular coordinate system. Suppose this is nothing but the origin. Suppose if the particle which is moving along x-axis, means what is the unit vector? Means what is the direction of particle along x-axis, means it is represented by cap and it is represented by j cap, and the particle motion which is represented along z axis nothing but k cap. Here I cap, j cap, k cap are the unit vectors along x axis, y axis, z axis. Means what is meant by unit? Unit vector means a vector whose magnitude is 1. Means, listen all of you, the magnitude of I cap is equal to the magnitude of j cap, which is equal to the magnitude of k cap, which is equal to how much? 1. That means a vector whose magnitude is 1. Whose magnitude 1 means the particle having only one directional motion. Means the particle which is moving only one direction, either along x axis or y axis or z axis. Okay. Now listen all of you. For example, if a bar be any vector, let us say I am taking. Now the unit vector can be represented by, the unit vector of a bar can be represented by a cap. A cap is equal to what is the meaning? It is generally defined as a bar by magnitude of a bar. A bar by magnitude of a bar. So this is the general expression for a unit vector of any vector, nothing but a cap is equal to a bar by magnitude of a bar. So listen all of you. Suppose if the particle which is moving along x-axis, means what is the unit vector which is followed by that particle? Means along x-axis I cap, along y-axis is j cap, along z-axis is k cap. Means suppose unit vector means particle having only unidirection, means single direction simply. Okay. Now for example, let us say here I am giving a bar is equal to generalized vector, for example I cap plus j cap. Then what is meant by unit vector for this one? Means I have to define a cap is equal to a bar by magnitude of a bar. That means a bar means I cap plus j cap by, what is the magnitude of this one? Root of I coefficient square, nothing but 1 square, again j coefficient square, nothing but 1 square. That means how much it is? I cap plus j cap by root 2. So this is the method to find the unit vector of any vector. Okay. Now after that I am going to the zero vector or null vector. Listen all of you. Zero or null vector means zero vector, or sometimes it can be denoted by null vector. That means the meaning of this vector is defined by only heading, means zero vector. A vector whose magnitude is 0, then that vector is said to be zero vector. Means for example, let us say for this one I am taking one example. Let us say this is the block. This is the block of mass m. Suppose here what I am taking. So these are the two persons A and B, which are standing in opposite directions. These two persons are trying to pull the block in opposite directions. Then what happens? So by a force, let us say F1 here, this is F2 here. For example, in this case, let us see if F1 is equal to F2, what happens? The net force acting on the block is 0. Net force acting on the block is 0, but its direction is indeterminate. Why? Because this block is moving either along a first x direction or either along towards A. Means here what I am saying is zero vector or null vector means a vector whose magnitude is 0, but its direction is indeterminate. A vector whose magnitude is 0, but its direction is indeterminate. This is indeterminate, or sometimes are not specified also. So this is nothing but the definition of zero vector. Now for this example, let us say this is the block of mass which is placing on the ground, and this block which is try to pull the two persons in opposite directions with a forces F1 is equal to F2. What I am taking here condition, if F1 is equal to F2, then what is the net force acting on the block? 0. That means this block is at rest. That means Listen carefully. If F1 is equal to F2 means the motion of the block I am not mentioning in this, because this block is moving along positive x direction or negative x direction, means towards B or towards A. Otherwise, I am giving another example for this. Let us say for 0 vector. So this is the bob which is suspended from the roof. Okay. Now listen all of you. Suppose this bob which is displaced through an angle displacement theta. Now at this angle displacement it is at rest only. Means at the maximum extreme position the bob which is at rest. This is nothing but the bob. Means at rest means what is the velocity of this body? Velocity vector is 0. But we can't specify the direction of this bob. Is it moving upward or downward or in this way? We can't specify in this. That means in this the velocity vector is 0, magnitude is 0, but direction is indeterminate. So these are the simple examples for 0 vector. Okay. Now what is meant by parallel vector? After that, what is meant by parallel vector and antiparallel vector and orthogonal vectors? So these are nothing but the types of vectors. So in the types of vectors, first I have to discuss about the unit vector, and after that 0 vector, and after that I am going to parallel vectors. Parallel vectors. That means if the two vectors which are in same direction, if the two vectors are in same direction, then these vectors are said to be parallel vectors. Means what is the example for this one? Let us say this is A bar, this is B bar. So these vectors are said to be sometimes these vectors are known as collinear vectors also, or sometimes it can be denoted by this way, this method also. So here let us say this is A bar, this is B bar. Now what is the angle between these two vectors? Here, what is the angle between these two vectors? Theta is equal to 0 degrees. That means parallel vectors means if the two vectors which are in same direction, means the two vectors which are aligned in same direction, then that vectors are said to be parallel vectors. Okay, I am giving the one example for this one. Let us say for this I am taking, this is x comma y coordinate, means two dimensional coordinate system I am taking. Suppose if the person which is moving along positive x direction A, and some other person also moving in this direction only B, then what are the unit vectors which is along the motion of A bar and B bar? Means here what is the unit vector along x axis means I cap. Means what is the examples for this one? Parallel vectors means for A cap means A bar vector is having a unit vector I cap, B also having unit vector I cap. What is the angle between these two? 0. Okay. So if the vectors which are aligned in same direction and which makes an angle theta is equal to 0 degrees, then that vectors are said to be parallel vectors. Then what about the antiparallel vectors? Antiparallel vectors. Antiparallel means the two vectors which are aligned in opposite directions. For example, let us say, so these are the two different vectors I am taking. One vector is along, let us say, positive x direction, another vector which are oriented in negative x direction. Then what is the angle between them? Theta is equal to how much? 180 degrees. That means theta is equal to 180 degrees. This is. Then what about the orthogonal vectors? Orthogonal, sometimes perpendicular vectors. What is meant by perpendicular or orthogonal vectors? If the two vectors which are perpendicular to each other, like this is A bar, this is B bar. Listen all of you. So this is A bar, this is B bar, which are inclined by an angle how much? 90 degrees. Then these vectors are said to be perpendicular vectors or orthogonal vectors. For example, let us, if I am taking the three-dimensional coordinate system like x-axis, y-axis, z-axis, then what is the unit vectors which is passing over the x-axis, y-axis, z-axis, which is represented by I cap, this is j cap, this is k cap. Here I cap, j cap, k cap are the unit vectors which is passing along x axis, y axis, z axis. Then these are the nothing but perpendicular unit vectors, because the angle between I cap and j cap is 90. Again j cap and k cap also 90. I cap and k cap also 90. So these are the examples, nothing but the perpendicular vectors. So perpendicular vectors means what the angle of inclination between them? 90 degrees. Okay, that is. So for parallel vectors, theta is equal to 0 degrees. For anti-parallel vectors, theta is equal to 180 degrees. For orthogonal vectors, theta is equal to 90 degrees. We have to remember these values. Okay. Now after that I am going to coplanar vectors. After this one, coplanar vectors. Coplanar. Coplane means same plane. Listen all of you. Again, here I am taking three-dimensional coordinate system x, y, z. That means the vectors here I am taking, let us say this is a cap, a bar, this is some other vector b bar. So like this. Now listen all of you. Suppose here I am taking three different vectors like a bar, this is b bar, let us say this c bar. These are all vectors which are confined to single plane. These are all vectors which are confined to single plane. Then this type of vectors are said to be coplanar vectors. Coplane means single plane. These are all vectors which are confined to here only xy plane. Suppose let us say for this one I am taking x axis, y axis, z axis. For example, here I am taking this is a cap, means a bar. Some other vector here I am taking this is b bar, this is c bar. The geometrical representation of any vector which is represented by arrow mark, that means here like this only. This is nothing but tail, this is nothing but head. So that's why here I am taking three vectors in this way. Here let us say this is a bar, this is b bar, this is c bar. These three vectors which are taken in different planes like xy plane, yz plane, zx plane. Then this type of vectors are said to be non-coplanar vectors. In this case more than two vectors which are not confined to single plane. Okay, that is. So non-coplanar. Coplanar means all vectors which are belongs to the same plane. Non-coplanar means more than two vectors. More than two vectors which are not confined to a single plane. Okay, that is. So this is the basic definitions of coplanar and non-coplanar vectors. After that I am going to another vector, nothing but polar vector. Polar vector. Polar vector. Polar means straight line, means a vector which produces a straight line, a linear or straight line, linear or straight line effect. A vector which produces a linear or straight line effect, then that vector is said to be a polar vector. For example for this one, let us say displacement. Means listen carefully. For example, I am giving one example for this one. Suppose if the person which is traveling on the road from, let us say, point A to some other point B, means the person which is moving in this way along this road. That means this person having certain displacement. Displacement means the shortest distance between initial and final, means the shortest distance from initial to final point. This is, and this means if the person which is having certain displacement has displacement means it has some velocity and the person gets some acceleration also. That means Here what are the linear vectors? Here displacement, velocity, acceleration are the examples for polar vector. That means if the person which is moving on the road means person gets some displacement, velocity as well as acceleration, right? So these are the examples for polar vector. Antena.